Let's review hypothesis tests when the population standard deviation is known, using our confidence interval approach. A magazine makes the claim that the average rent in northern BC is exactly $1,000 a month. You decide to test that statistic. You get 30 household samples with an average of $1,060. You happen to know the population standard deviation is $150. Test the statistics with 95% confidence. So step one will be to create our hypothesis. Our null hypothesis would be the magazine's claim, which is that the mean is $1,000. Our alternative hypothesis is that the mean or average of rent in northern BC is not $1,000. So now we're going to be testing this statistic with a 95% confidence level. So if you can recall from our last part, where we used our confidence intervals when we knew the population standard deviation, we had the following formula. Where x bar equaled the sample average z-score of alpha divided by 2 is the z-score of the confidence interval Now in this case, this is a common confidence interval, 95%. If we have a look at our formula sheet, we will see that 95% is 1.96. Our standard deviation is our population standard deviation. And n is equal to our sample size. So let's determine this. We have our sample average of 1,060 plus minus 1.96 multiplied by 150 over the square root of 30. We then get 1060 plus minus 53.65. So if we were to less 53.65 to 1060, we would get $1,006.35. If we were to add that, we would get $1,135.65. This is our range to a 95% confidence level. When we have a look at our hypothesis, our null hypothesis, it shows a $1,000 mean. So we can see that that falls outside of our range to a 95% confidence. So we could reject this null hypothesis. Now, if this had been within our range, we would not reject it. Now this is not 100% confirmation that rent is greater than $1,000. It's just that there's a lot of evidence that it is. So that is why we would reject it. We could have an error here, but with a 95% confidence, we can safely reject this.